In this video, we're going to talk about the different components within a relational database, starting with really basic stuff. So here I have this grid right here, and this represents a table. A table contains all of the detail related to a class, so all of the attributes and data related to specific groups of items. Inside of my table, along the columns, I have column headers, things like ID and name and address and email. All of these columns represent different attributes, right? Or things that describe the objects in my table. If I look at this in the lens of a UML diagram, where I had people and the different attributes like ID and name and address, this is what it translates to in a physical table. Now, as I record inputs, each of these rows represents a record. So ID 101, that's going to be Teeter, address, Linden Avenue, something at pitt.edu. Okay, so this is one person represented in this row. Think of it as maybe an individual. And then I have 102. This would be Professor Boyas, who lives on Shady and has, a different email address. So another individual represented in a row. And then I have another record, 103. This could be another professor who has another email address and so forth. So all of these things are representing different individuals. There's a technical term for each of these rows called a tuple, but you don't necessarily have to remember that. Just know that each one of these rows represents a single individual. It could be a person, it could be a transaction, it could be an inventory item. All of these are here. If I look at an individual cell here, so the intersection of name and individual, that is called a field, or sometimes it's called a cell. If you ever fill out an internet form and you have to put in your name and address and so forth, that form and those boxes correspond with an entry in a database, in one specific cell of a database. The piece of data that we put inside that field is called a value. So the value for the name of individual 102 is Professor Boyas. One last thing I want to mention, sometimes we can have fields that are blank, that have no value. If we have a blank value, we call this null, or blank. So if it is null, it has no value. So this is how we store data. Now let's take a look at one of these individuals. If I wanted to capture the information for this individual, I'm going to use something called a form. And this is what you see on the internet all the time, or when you fill in an application online. So a form is a document where it's going to ask me for my ID, and it's going to give me a box. It's going to ask me for my name, and a box, my address, and my email. So each of these form fields corresponds with an individual value and record. So here I have ID 101, this is Teeter, lives on Linden, email is teeter@pitt.edu. The important thing to remember about forms is they show only one record at a time. Meaning if I want to see Professor Boyas' entry, I have to click the next button and go over to her entry. It's going to go one record at a time on that field. Now let's go back and review something from last week. Last week we were talking about classes, and we talked about different types of keys within these fields. We had primary keys, foreign keys, concatenated keys, and non-key attributes. Do you remember what our primary key represents? It's a unique identifier for each of these records. So my ID right here, that's going to be my primary key. Now with primary keys in databases, there are a couple rules that we have to follow in order for a database to be valid. And the rule related to primary key is something that we call entity integrity. Entity integrity, and you want to remember this. Remember, entity is like an individual. With entity integrity, there are two parts to this rule. The first one is a primary key must be unique, meaning I cannot share this key with anybody else. My number here, 101, cannot be used by anyone else. Just like your student number cannot be shared, or your social security number is unique to you. These are all unique identifiers. Within databases, there's a second rule to this, and this is that a primary key cannot be null. What does null mean? It cannot be blank. What this means is that I cannot create an entry, say for Professor Teeter, without first assigning me a primary key value. It will not let me validate the data. I cannot save the data. In most cases, when you come across different websites and you're putting in forms, the primary key is going to be completely invisible to you. Meaning you'll put in your information and the database, when it creates a new record, will automatically assign you a number. Just like when you create an account at the University of Pittsburgh, it automatically assigns you that PeopleSoft ID. You don't get to choose what it is. Foreign keys also have a rule. Do you remember what a foreign key is? A foreign key is an attribute that refers to the primary key in another table. So we use it to link tables together in a relational database, or link those classes together. So with a foreign key, it has its own special rule. We call it referential integrity. And referential integrity means that it refers to something. Two parts to this, just like we had with the primary key. The first part, a foreign key must reference an existing primary key. Meaning that if I refer to person 213 in a transaction, what this first rule means is that if I'm referring to person 213 in a transaction, that person 213 has to exist. Meaning I can't refer to somebody that doesn't exist in the system. However, unlike primary keys, the second part of this rule is that a foreign key can be null. Remember, null means blank. If I refer to person 213, 213 has to exist, but I could refer to no one and just leave it blank, and I could be perfectly fine. So it either has to match something that exists, or it has to be empty. Remember these two rules, they're very important. Entity integrity with the primary key. The primary key has to be unique, and it cannot be blank or null. A foreign key must refer to a primary key that exists, but it could be blank. We use this, by the way, to express optionality with that cardinality. We use this last part, by the way, to express relationships that are optional. Remember back in cardinality last week, if we have a minimum 0, that means that there's going to be a blank foreign key somewhere. So these are major components and definitions. I want to take a moment and talk about numbering. When we talk about numbering, numbering relates to how we choose primary keys within our system. The unique identifiers that we're going to use to identify objects or people or places or things. So with numbering schemes, there are 4 major types of numbering schemes that we're going to come across as we interact with data. And each of them serves a different purpose. The first one that we see is something called sequential numbering. Sequential numbering means that we're going in sequential order. So if we have a number that's 101, and then 102, 103. These are really useful. We want to make sure that all of the data are there. So it's very useful for internal controls. For things like checks or transactions. What this allows us to quickly see is whether there were duplicates, meaning that I have a check that is the same number as another check that's already been processed, or if I have gaps in the numbers, meaning I go from check 101 to 103, that means check 102 is missing somewhere, hasn't been recorded, or maybe somebody deleted that record. So sequential numbering, we're just going in sequential order. The second type of number that we're going to see is something called mnemonic. And this one's a fun one to spell, M-N-E-M-N-O-I-C. Mnemonic means that we are going to be looking at combinations of numbers and letters. So we may have A, B, C plus 1, 2, 3. So think about where would you see mnemonic numbers if you're out in the world? Well, the most obvious one would be things like license plates. And why do we use numbers and letters on license plates? Well, it comes back to mathematical permutations and combinations. Remember that if we look at the combinations of 26 letters and 10 digits, even with a short code like this, we can have very large numbers of items with very short codes because the potential combinations are in the millions. Another place that you're going to see mnemonic devices would be, another place where you're going to see mnemonic numbering will be in Amazon products. Stop and do a quick search for a product on Amazon. You can click on whatever's on the front page or search for something like, I don't know, a shake weight. When you click on that, if you look at the URL, the address, you'll see Amazon.com and a bunch of codes, and then you'll see something that looks something like B007HQ32. That number is the inventory primary key for every single item that is listed on Amazon. It doesn't have to be very long because it's a combination of numbers and letters, so you can have billions of products with a fairly short code. The third numbering scheme that we're going to look at is called a block numbering scheme. And we use blocks when we want to track things that have categories. So categories of products and so forth. So we focus more on the first digit. The first digit will represent different categories rather than the rest of the number itself. So some examples of block numbers. Think about room numbers. If you look at a room and you're going to Mervis 201, by looking at the room 201, you can see that the number 2 means that that room is located on the second floor, a category of rooms. If you look at another number, 326, you can tell automatically that that one is on the third floor, based on the first digit. Another place where we're going to use block numbers, where we care about categories, especially in accounting, is when we look at our chart of accounts. If we were setting up the chart of accounts for a small company, we could use that first digit to represent the different categories of accounts. For example, our 100 accounts may be our assets. 100 may be cash. 110 might be accounts receivable. 115 might be our allowance account, and so forth. Our 200 accounts would be liabilities. Our 300 accounts, expenses. Our 400 accounts, revenue. And our 500 accounts, equity. So looking at our chart of accounts, you can see what class of accounts that was. One final place where we're going to see these block accounts will be in football jerseys. So the football jersey is going to tell you what position you play on the team based on that first number. If you search football jerseys on Wikipedia, you can quickly see what number is going to be your quarterback, your running back, your lineman, special teams, and so forth. And that'll give you a hint when you're looking at the team the next time you watch a football game. Finally, we have group numbers. And group numbers are a special category of numbers because what it means is basically we are going to create a long number that includes different parts that represent different components. And our groups represent different things. The other thing to remember about group numbers is that these can be combinations of other numbering schemes. Let's look at a basic example of a group number. Here we have a phone number, 412-555-1212. This is an example of a group number because each of these groupings of digits represents a different thing. The 412 is my area code. The 555 is my municipality. And the 1212 is just a number. The area code is given for different regions. The municipality may be a good example of a block code. Everything starting in a 2 could be in the Pittsburgh area. Everything starting with a 9 could be in Philly. And then the 1212, this could be a sequential number, where I have numbers that go up, and the provider is going to assign the next available number. Can you think of other examples of group numbers, where you have long codes and each of the numbers represents something? I'll give you a couple examples. One is a vehicle identification number, a VIN. Look this one up on Wikipedia, and you can see what each of the different components means. Some of the numbers represent the make or the model, the year that it was built, the features that it has. A Social Security number used to have more meaning to it, so it would tell you which regional Social Security Administrative Office you got your ID from. Now they've made it a bit of a random number to make it more difficult to fraudulently create Social Security numbers. A credit card number. The first 4 are going to be your issuing bank, followed by 12 other digits related to your account number. So again, these group numbers are kind of a special case because they can combine block codes, sequential codes, even mnemonic codes into a more complicated scheme. The last example related to accounting is going back to this idea of chart of accounts. Do a quick search for the chart of accounts for the University of Pittsburgh. It will take you to the CFO's office and it will show you what a 32-digit chart of accounts number represents. Each different group is going to represent the school, the block, the area of funding, the department, even down to the employee number. Whenever I want to buy something for class or for my office, I have to find this 32-digit number to be able to tie it to my specific account. Also make note when you look at this at the numbers reserved at the end. So there are an additional 5 or 6 characters that are not used currently, but they're built into the system so that if there were some future use, they already have a numbering scheme so they can adapt really quickly without having to revamp their entire numbering scheme. In the next video, we'll continue talking about databases and something called normalization, how we break things apart to make them more efficient in storing our data.